Well, hello again, Year 7s. Quick joke to get this one started. Have you heard of the band called 1023 MB? Yeah, they haven't got a gig yet. That's one for the computer nerds out there. See if you can work that one out. Anyway, let's move on really quickly. Still continuing with our probability section of this chapter. So we're now looking at exercise 8H, theoretical probability. All right. We're going to be looking at two things: theoretical probability in the next video, experimental probability. All right, so what do you think the difference is there? Well, theoretical being what we'd get theoretically. So what would be the probability theoretically of rolling a 4 on a dice? All right, compared to experimental probability where we actually carry out trials. Okay, we get a die, we roll the die a number of times, 10 times, 20 times, 100 times, and we work out exactly how many times a 4 occurs, okay, from rolling that die. So that's the difference. So theoretical is we are predicting what we should get roundabout, okay, where experimental we actually carry out the trials and we work out what we actually do get from those trials. Okay, so a few things that you need to note down on your note-taking sheets. What an experiment or a trial is, which could be tossing a coin, rolling a die, or spinning a spinner. Okay, that's what we mean when we talk about a trial or an experiment. I often refer to it as a trial, but make sure you know both words, they're interchangeable. An outcome is a possible result of the experiment, like the outcome of rolling a 5 or the coin when you throw it showing the tails is an outcome. An event is either a single outcome, all right, so it could mean, yep, example for rolling a 3 and a die, or it could be collections of outcomes, okay, rolling a 3, 4, or 5, or rolling an even number, or rolling an odd number, for instance. So yeah, an event can mean one single thing, or it could mean a number of things that we designate could happen, okay. Probability, spoke about that a little bit in our last video. So the probability of an event is a number between 0 and 1. As we said, it can be written as a fraction, can be written as a decimal, could be written as a percentage, okay? But it is usually between 0 and 1, okay? Yeah, to represent the chance of a particular event occurring. So the probability of an event occurring, if all outcomes are equally likely, is. Now this is the important, I'll try and draw this line really carefully, formula that you need to make sure that you're right. Okay, so whenever you're trying to work out theoretical probability, this is what you use. So PR, whenever you see PR, that just means probability. Okay, it's just a shortened version of the word probability. So the probability of an event equals the number of outcomes where the particular event occurs. I think I rewrote this somewhere. So the number of ways an event could occur is that top one. So the number of ways that an event occurs. So for instance, if we're rolling a die and we say the probability of getting an even number, how many even numbers on a six-sided die? Well, there's 2, 4, and 6, so there's 3. So that would be your top number, okay? And the bottom number is the total number of possible outcomes you could possibly get. So if you roll a six-sided die, there are 6 possible outcomes: a 1, a 2, a 3, a 4, a 5, or a 6. All right. So yeah, that formula is really important. It's important that you write that down and you've got record of that, all right? Because that's what you use always to write your probability. So you're going to write it as a fraction, and then if needed, you're going to switch it around to either a percentage or a decimal, depending on the question and what the question's asking. All right, so the number of ways an event can occur, and then the total number of possible outcomes that there are for that particular trial, all right, or that particular outcome that you're talking about. Okay, so probability is often written, as we said, as a fraction, but it can be written as a decimal and or as a percentage. We covered that. The sample space, I covered that in the last video as well. Okay, is a set of all possible outcomes of an experiment. Okay, so if you remember, there's the sample space of where can I write this? Of a six-sided die, for instance. Okay, you write your squiggly lines and you write, whoops, don't want to write a 6. You write all the possible 3, 4, that is a 4, 5 and 6. Alright, it is just a list of all the possible outcomes. That is called sample space. So all possible outcomes in an event. Okay, if we're doing heads and tails, again, squiggly lines, heads, tails, squiggly lines. If it was a spinner with different colours, then you write different colours. You know, red, blue, green, yellow, whatever it is, whatever colours are on that particular spinner, for instance. Alright, so that's what sample space means. If you're asked to write sample space, that's all you're doing is writing all the possible outcomes that could occur. Alright. We write probability of green. Okay, so when you see that, that means we are after what's the probability? That's our question. What's the probability of getting a green? Or the probability the spinner shows green, or green coming up, or if you got a die with different coloured faces, the probability of green showing on the face of the die. Okay, but that's how we write it, and you'll see that quite often as we work through the next couple of exercises, that's how the question will be asking. It will be asking you, find the probability of green with this particular spinner or die, or whatever the case may be. Okay, or probability of rolling an even number, or probability of rolling 1, 2, or 3, for instance. Okay, but that's what you'll see, and that's what it means. We've gone through this, so I've got word descriptions. We went through that in the last video. I'm not going to go over that again. Probability here is fractions from 0, which is impossible. Okay, right up to 1, which is certain, or 100% will happen. Okay, so it is certain that the sun will rise tomorrow. Okay, 100% 100% chance of that happening. All right, and then everything in between occurs there. All right, but this is the key thing, because this is what you're going to be using to answer questions. So I have got that in the next slide. So what I want you to do, you're going to do this. We'll come back and answer it together. So a fair six-sided die is rolled. Okay, you need to go through these questions. I've got the little formula here for you to use as a reminder. So I'm going to pause this. You need to go away and do it. So make sure you pause it, and when you're finished, we'll press play and we'll cover it together. Off you go. Okay, welcome back. And here we go. Let's get through this. Keep this video under 10 minutes. Okay, a fair six-sided die is rolled. Part A, list the sample space. And this is what your answer should be. If you didn't write sample space, don't be too concerned, but in future, write it exactly like this. Model what I do. So sample space equals 1, 2, 3, 4, 5, 6. Okay, that's simple. Covered that in the last video. That should have been a soda for you. Find the probability of rolling a 3, giving your answer as a fraction. Okay, so using our little formula up here, number of ways that a particular event could occur. So we've got a six-sided die. The probability of rolling a 3, that's all we want, one single event, a 3. How many ways can a 3 come up? Well, once. Okay, the total number of possible outcomes. Well, there's 6 possible outcomes, so our answer there is 1 over 6. Okay, that's your answer for that one. That's how easy it is. It's really, really easy. Find the probability of rolling an even number, giving your answer as a decimal. So we're going to write this as a fraction first. Okay, so the number of ways that an event can occur. So how many even numbers come up on a fair-sided die? 2, 4, 6. So there's 3. Okay, bottom number, total number of possible outcomes. So again, a six-sided die, there's 6 possible outcomes. We write it as a 6. 3 over 6, which equals 1/2. Let's simplify that down. We need to write it as a decimal as the last part of our question to get our answer. So 1/2 is a decimal, 0.5. Okay, that easy. Last one, find the probability of rolling a number less than 3. And this time, so less than 3, give your answer as a percentage. Okay, so be careful, this is less than 3. Less than, not less than and equal to 3, so less than 3. So the only options we've got there is 1 or 2. It's got to be less than 3. So the number of ways an event could occur, well, it's either rolling a 1 or a 2. So that's 2 out of possible number of outcomes. Total possible number of outcomes is 6. 2 out of 6, which, simplify that, is 1/3. 2 goes into 2 once. 2 goes into 6 3 times, so 1/3. And we need to write that as a percentage. So make sure when you do this, you've got to write as a percentage. So 1/3, which is 33, and I'll do that to one decimal place, 0.3%. All right, you could also use a calculator. Give me a sec, I'll bring my calculator up if you want to use a calculator. 1 over 3, remember that line, sorry, bear with me for a sec. I'll get this. Remember that line here is a division. Okay, that means divide. All right, so if we do 1 divided by 3, okay, gives us this a decimal. We multiply that by 100 if we want percentage. Okay, and we get 33.3 recurring. So let's just go to one decimal point and 33.3. All right, so that's our answer for that one, and that's it. Alright, this is just hitting 10 minutes now, so I'm going to sign off. Hopefully that makes sense to you, but use that formula. That's the one to use, and that'll get you the right answer. Thank you, guys. Bye-bye.